Morning, everyone. My name is Deepak. Today I'm going to present about Project 3, converting land to sources. So before getting into it, this is about what is sequential logic. Sequential logic is a type of logic in which the output is dependent on the previous input. Like suppose we are giving some inputs, which will be getting some outputs. Those outputs are independent, like will be dependent of before inputs. Or if you're giving some new inputs, those inputs will be dependent on the previous outputs. It works in the form of clock cycles, like 1, 0, 0, 1. The sequential logic, the hardware should be memory to store data. The clock cycle works in form of unit of time. Each input will be reflected in the output and changes any clock cycle. The output does not change instantaneously, but changes over short periods. For example, the clock may change in one time period, that is 0 or 1, like this in this example. And the input and output may also change for the given NOT gate, OR gate, AND gate, or XOR gate, and many other gates. And what is a combination logic and sequential logic? Combination logic is a type of digital circuit where the output is determined by combination of current input, not dependent on previous input. Sequential logic is a type of digital circuit where output is dependent on current output and previous output. For example, in this combination output, here in the time one, the function is dependent on function A, the time two, the function B is dependent on function B. But in the sequential output, you can see the function is dependent on t minus 1, that is the previous time input. For A, it will be having for function of B, it should be dependent on function of A. Flip flop. Like what is this flip flop? In digital circuit, flip flops are a type of circuit elements that can store one bit of data. They are used to store and transfer data between logic circuits and memory. Flip flops are a type of clock circuit, means that they will need external signals called a clock to control whether to store the data or transfer the data. Flip flops are an essential part of modern digital circuits and are used in everything from computers to communication systems. Here it is a set preset type. Basically, the data storage device which holds the data until reset occurs. In the JK type, where JK will be different inputs. For set reset, if the input is 1 for the set, the output will be the input for the reset will be 0. For JK, four combinations are possible: 0, 0, 1, 0, 0, 0, 1, 1, 1. And the for D type will be having only one input and two outputs. And the topology is the same. Basic data flip-flops have advantages, simpler than JK version. In the JK version, two input behaviors plus toggle behavior. Now, what is a toggle? Toggle action is used for counters. Counters can be 1 or 0. It can be constructed from any type of basic flip-flops. D flip-flop. Basically, the D flip-flop has one input and two outputs, and it has a clock cycle. And the four combinations of clock and D are represented as 0, 0, 0, 1, 1, 0, 1, 1. And the outputs are given Q, Q dash. D flip-flop is a type of flip-flop that stores one bit of data. This type of flip-flop is often used to store the current state of digital circuit. A D flip-flop has two inputs, and D clock. When the clock signal is high, the data at the D input is stored in the flip-flop. When the clock signal is low, the data stored in the flip-flop is empty. Remember, the input of clock cycles and gives it out in the next clock cycle. The first clock cycle, there won't be any output, as we don't know what has happened. Generally, the formula for the D flip-flop is out of T is equal to N of T minus 1. What is a 1-bit register? Usually, 1-bit register stores all the 1-bit values until it processes. For example, if the data, like the output will be like in the clock cycle, the load will be 1 until we give a new input. See here in the bit, if load of t minus 1, then out of t is equal to n of t minus 1. As you can see, if the clock cycle is 1, the output has changed to 0. Now, what is basically one human architecture? The one human architecture sometimes referred as one human model. It is a type of CAO, that is computer architecture, that is based on the design of computers developed by John von Neumann. The von Neumann architecture is based on the idea of single memory that both stores data in instructions as well as central processing unit that can execute instructions and process data. This type of architecture is widely used in modern computers, although there are some variations. Computer system, input, output, memory, and it has ALU, which has the CPU and the control unit. RAM unit. Random access memory is a type of computer that allows a process to read, form, and write with unit. RAM is used to store the data and instructions that the processor is currently using, and it shows that has been recently used. RAM consists of n registers stacked together, and only one of them is used in the load in and load one. To read from RAM, the address is set to register enter, and data is outputted. Counters. Basically, counters increase the input values. Counters are used to keep track of network positions and check whether instruction is to be executed or not. PC++ use next instruction. C is equal to n minus. Go to the nth instruction. Now let's go to the simulator part. In this simulator part, we'll be demonstrating ha- RAM 64, and here it has one input, one load register, and one address. First, suppose we give the input value as 7, 6, and the load value is 1, and the address value is 5. And let's give a clock cycle. As you can see, the input is 6, and the address, that is, should say, let the address be 4. As you can see, in the address 4, that is the 4 part, will be loading one value, that is the input value 6. Suppose if we give an address value 5 and the input value is 56, then in the address value 5, that is here, will be giving an input value 56 after the load value of 1. First, suppose if we give this address value as 3 and give this load value as 2, after 3 clock cycles, we'll be getting the value of 56 in the address value 3. Yes. After 3 clock cycles, and here the 5 plus is the time counter, that is the number of time clock cycles it has been occurred. So this is all about the hardware simulator of RAM fixed for clock cycle with input value, load value, and address value. Thank you.